I'm going to explain, this is my third video on gyroscopes, and this one is dealing with this concept of precession, which is the torque. They call it torque. I don't like this word because it doesn't tell you anything. It's like, I'll give it a fancy word and then you'll know what it is, but you won't know what it is. Now, the gyroscope, for my example, is going to be on the corner of the desk, but it's going to be leaning over like this. It's going to be on its side like that, and it's going to be, and when you put a gyroscope on its side like that, it starts to rotate. The whole gyroscope starts to rotate in this plane. And then you'll see it here, you'll see it there, and so on. The whole gyroscope rotates. This is spinning, and that's why the whole gyroscope rotates. And that they call it precession, and I'm going to explain in a similar way the way I explained the other things. So let's say we're looking at the corner of a desk here, and we're almost at eye level. We're looking straight at that corner. Let's say the spindle of the gyroscope is facing us, pointing towards us. The gyroscope's leaning right over, so we've got a clear view, overhead view of the gyroscope, although it's on its side. And let's say that the gyroscope is rotating in this direction, clockwise. Now, as I said, the whole gyroscope, imagine a ring around this pen, that's the gyroscope, will rotate like that. And why will it do that? We're going to have some values here. I'm going to say that gravity has a value of 10 to start with, okay? So let's say that gravity equals 10. And let's give the gyroscope a velocity of 50. Now, this point here, travelling in this direction, and the gravity's given it 10. It's given it an extra velocity of 10. So the velocity's actually 60 at this point. Then when it gets to here, sorry, the momentum is 60 at that point, not the velocity. When it gets to here, we've got 9, let's say, of velocity. We're adding 9, we're adding 10. When it gets to here, so we're adding 8. It's just because it's a mechanical system, it's going to lose. It's going to add 7 here, and it's going to add 6, it's going to add 5, it's going to add 4, it's going to add 3, it's going to add 2, and it's going to add 1. And those are the directions. Another thing happens here, we've got gravity working on this bit as well. We won't worry about the gravity working here because it's not going to affect it too much, because this gravity, whatever it does, will change into pulling it that way, and this gravity will change, oh, that changes into pulling it that way as well actually. Look at that. Oh, well, okay. In that case, we will. Gosh, I didn't realise that. Okay, so oh, right, let's do all 4. This is even better than I thought it was. We've done this one. So here we've got gravity of 10, haven't we? Gravity of 10. Doesn't do anything for the sideways, so let's go to this one, and that's going to give us, it's going to give us an entire 10 in this direction. Wow. Okay, it's going to give us 9 lifting it in this direction. It's going to give us 8 in this direction, by which time 7, 6, again 5 lifting it, 4, 3, 2, and a 1. Okay, so we're going to have a lifting effect of 15 here. How much is gravity? 10. So the gravity is lifting it by an amount of 15 units of momentum I'm talking about, is going to give us 12 in this direction, pulling it back that way, but it's going to give us 18 in that direction. Okay, we've got another 12 in this direction as well here, and 10, 18 downwards, that doesn't count. We've got 10 taking it down there for the 15 taking it up, so we've got 5 lifting, and then we've got 9, 10, 15 here taking it in this direction. When we get to here, we've only got 10 taking it in this direction. So you see the biggest one is here. This is our biggest number, and that's going to make your gyroscope rotate that way. Now these numbers are not obviously exact and accurate, but the more times you go around with it, the more you're going to get an accurate amount. I haven't done the equations for it. I don't know the exact amounts of the forces relative to each other, the gravity and how it converts to momentum, but if you take my basic premise that gravity becomes momentum, and this point here takes a bit of momentum from the gravity and transfers it to here, as I said, the general principle will stand. And I can just do you a simple diagram just to make it really clear why, although this obviously doesn't take into account all the forces here. But we've got, if we just look at this one thing, which is these 2 points here, and the gravity working on them. So this is gravity, and this is gravity, and it's rotating clockwise. When this arrow gets to here, this momentum, it's taking it that way. But when this arrow gets to here, it is also taking the gravity, the momentum, that way. Do you see? So it doesn't matter how you crunch the numbers, the overall net gain of momentum will make your gyroscope rotate like that. And it was just an added bonus that I hadn't realised, that when we've got gravity working on this bit here and this bit here, that by the time it rotates, they are both also moving the entire gyroscope in that way. So you've got every single force on this gyroscope. Let's just imagine, okay, that my pen is the direction of the gravity pulling, and the gyroscope's rotating like that. Look, now it's pulling the gyroscope that way, okay? And then we've got a bit of gravity here, pulling it like that. And look, now it's pulling the gyroscope that way. And then we've got another bit of gravity here, pulling it downwards, and it gets to here, and now it's pulling it around again. And we've got some gravity pulling this point here down, and look, as the gyroscope rotates, it pulls it that way as well. So all gravity, that one becomes that, that one becomes that, that one becomes that, and that one becomes that. So can it be any clearer than that? All these downward forces, when you turn it clockwise, pull it that way. And the reason, obviously, within 180 degrees, they're going to be pointing the other way, those arrows, but it doesn't matter because we're working with a system that is losing a bit here and there. I'd be very interested to know whether, if you had a gyroscope that was 100% efficient, that didn't lose any energy whatsoever, whether because I haven't done the maths, but I've got a feeling that the maths, I don't know. I think a gyroscope that's 100% efficient would just spin and not move at all, because it would have to be in outer space, so therefore that by definition. But you can see everything's making it rotate. I hope that's clear enough. Layman's explanation of precession.